Okay, we're recording. Okay, good morning and good afternoon to everyone. Nice to see a few of you on this. We did we're doing a couple of sessions today on this particular topic to introduce people to a fairly new product for Matrix, which is our fundamental fluids system. So this webinar is going to be about half an hour, not much more than that. And the webinar is designed to introduce you to this new system from Matrix, introduce you to how it works, the features and system benefits of this particular new product, and how it fits into the Matrix portfolio as well. We're then going to run a demonstration with you, and we're going to show one of the experiments taking place. So we're going to show characteristics of pumps using the system that we've got here next to us, and Michael, one of our engineers here at Matrix, is going to do that for us. Before we do that, I've got a short presentation that I'm going to run through. I am just going to, in fact, I think I've already muted everyone's microphone, but if there are any questions or comments, please feel free to unmute yourself or use the chat function that's available as well. So just bear with me. Okay, hopefully you can see the screen that we have here now, which is the fundamental fluids main screen, essentially. We have got here a graphic or an image of the system. I'm going to start off by just introducing you a little to Matrix and who we are, how we're set up as a company, some of the products that we've got, and the areas of engineering that we cover, because I know that some of you may be unfamiliar with our company. So I will start off by doing that. We're then going to quickly move into the features and benefits of this new product, show you what's included, talk through the curriculum, give you a demonstration, and answer any questions that you may or may not have. Okay? So to begin with, let's just kind of take a step back and just briefly introduce you to Matrix for those that aren't aware of us. We're a company based in a town called Halifax in West Yorkshire here in the UK. I'm here in our facility now. We were founded in 1993. We're still a privately owned company, so we're almost 30 years old now. Today we have a portfolio of over 100 products which offer a combination of hardware, software, and curriculum, learning manuals, and teaching curriculum for technical education. So we specialize specifically in college, university level education, age 16 and above. We invest a huge amount of money, particularly in more recent years, into R&D. So we have our own in-house R&D team who design the solutions that you are aware of for education. Also, we have products now that span various different disciplines. So that you'll see a graphic on the right side of this screen, which outlines the areas of engineering where we have particular products. So for electrical engineering, we've always been relatively strong in this area. We have products including our electrical machine systems, Locktronics, E-blocks, and others, which have been around for many years in education and are very popular in the electrical engineering world. But in more recent years, the last 3, maybe 5 years maximum, we've also developed a range of products that are more specifically appealing to those teaching more manufacturing type engineering disciplines, such as CNC machining, PLC training and programming, Industry 4.0, robotics, pneumatics, and so on. And then in the last couple of years, we have started to grow a portfolio of products for mechanical engineering. We began this by last year introducing our fundamental mechanics range of products for statics, materials, and dynamics. We then launched a range for study of structures principles, 7 different products in that range. And just in the last couple of months, we have brought to market a new product for study of fluids, or fundamental fluids, as we call our new product offering. That allows us to now encompass 3 very distinct areas of engineering in a way that no other supplier in the market is able to do. We cover the principles. We have some really cool features to our products as well, which we'll go through throughout the presentation. And then we also cover other disciplines. In the boxes at the bottom there, we have products for aviation and automotive, science and electrical installation. So we're a very well established company with a good, strong portfolio of products that are selling really, really well all over the world. Yeah, we now sell into over 50 countries, 50 to 60 international agents or dealers who sell these products. And we sell over half of what we ship now outside the UK. So more than 50% of our goods go to all corners of the globe, from Australia to South America, Canada and the US to the Middle East, UAE, right through Asia as well. I have on this slide just popped our contact us details. So you'll see the website, matrixtsl.com. You can go there and see information about this particular product we're going to look at today, as well as other Matrix products. You can email us anytime, sales@matrixtsl.com. If you're emailing us from a specific country where we have a dealer established, then straight away we'll put you in touch with them so you can work closely with them. Or you can give us a call as well with the number that's on screen. I'll pop that information up again before we finish this presentation. Okay. Okay, so first thing is to look more specifically at fluids and fundamental fluid system that we have. Most of you will be very familiar with fluid mechanics, but for those that aren't, I've just put a very short, simple statement at the top about what is fluid mechanics. And fluid mechanics is the study of the behavior of fluids. That could be liquids, gases, blood, plasmas, anything that is a liquid, both at rest and in motion. Fluid mechanics has a wide range of applications. Now, we specifically look at the curriculum for teaching in mechanical engineering context, but that is closely related to chemical engineering and other disciplines as well. Okay. In terms of what Matrix have to offer them more specifically, our fluids range gives students a hands-on understanding of the key principles of fluid mechanics. So that's the core aim that we have from this particular product. We provide a main workstation. We'll show you on the slides that are ahead, alongside 16 individual components. This comprises of apparatus, hoses, tubes, and connectors, which allow students to build 9 different experiments without the need for any additional tools other than what we provide in this kit. Out of the 9 experiments, 6 of them are connected via USB to pressure and flow sensors, which allows results to be automatically plotted in the application, which we'll show you, on a graph for further analysis, or exported into a document such as a CSV file for analysis by the user. The other 3 experiments that we have in this product are carried out and plotted manually by the user. Just on the right side of this screen, there is a video linked. One of the things that we are endeavoring to do as a company more of is to produce video content that allows us to explain and show these products in use. So I think there are 4 videos for the fluids range. One is an overview introductory video explaining a little about this presentation, for example, what's in the kit, what this kit is designed to do. But then we also have 3 experimental videos which show actual experiments, and the 9 experiments indeed being conducted. So please click on that link. We can share this with anyone that wants it afterwards, and you can see those videos. Alternatively, just go to the YouTube via matrixtsl.com. So system benefits. One of the important things to talk about with our system, and again we'll be looking at it in a little more detail shortly, is the fact that this system is manufactured here in the UK. One of the big things that we've done as a company over the recent years is to move more and more of the manufacturing of our products for education in-house here in the United Kingdom, so that we have what are truly UK manufactured products to supply to the global market. This is done for a number of reasons. First of all, we're very much in control of the quality of the products, and that is one of the benefits of this particular system with the fundamental fluids. Another reason is that we are able to also react as quickly as possible to the market needs. So if, as a potential customer in the market, you are looking for equipment inside a maybe shorter time period than our competitors can offer, we're often very good at being able to do that. And so there's a number of reasons why we've brought manufacturing of these type of systems in-house, and the whole portfolio that you'll see on matrixtsl.com is manufactured here in the UK. Other benefits of this particular system are on screen now. First of all, something we take very seriously because we deal with education. We understand the challenges that equipment can go through when it's being used day in, day out by students. And so we have to take into account the rugged nature of the equipment that we provide. So with this system is steel metalwork, which stands up to an educational setting and the challenges that will be thrown at it by students as it's being used heavily over a number of years. So this is a very rugged system that's not going to break easily or anything like that. Underneath that, the second benefit of this system, one that we differ in from our competitors and others in this market, is that we provide the controller for the system as a built-in part of the offering. We'll show you that shortly when we show you this system. And we'll also show you applications, software, calibration apps, which are all free of charge, downloaded from the Matrix website. Others in this market will offer you a data acquisition system, which is a controller or a box, which has to be purchased separately, often for quite expensive amounts of money, whereas we build that into the whole system. And that's a real benefit of our offering. Just on one there, the bottom in the middle, we have one kit here. There's no modularity to this kit. The kit is a full kit, a full system that provides 9 individual experiments, and we'll go through the learning objectives and experiments covered a little later in this presentation. Talking about the learning objectives, that brings us nicely onto the curriculum. And one of the concepts that we have as a company is that we provide curriculum absolutely free of charge. Again, others in the industry will explain to you that curriculum is accessed once you purchase and buy into a learning system from them. Whereas from Matrix perspective, we take a different approach. And instead, on our website, you'll find the Learning Center. In the Learning Center is all of our curriculum absolutely free of charge. And that includes the curriculum for the Fundamental Fluids product. So please be sure to check that out. Another thing that we've been very keen on doing over recent years in particular is producing products that are able to be stored away very easily and are portable, so they can be moved from one lab to another with real ease. We've done this because we understand that in education, space is at a premium. Many in engineering, many competitors are producing huge equipment that has to be in a set lab, which works well often, but often the ability to be flexible with a portable system is much better. There are other benefits to that as well. This is a low power system, 24 volts runs this system. And as a result of that, there are no safety concerns or anything like that. The small nature and the pricing of this particular offering means that you can often have multiple setups in one lab, meaning students can get hands-on quicker and start using it really easily. The way that this system is stored is ingenious. We'll show you that shortly. But the whole experiment components are bolted to the front or the back of the system with an enclosed case on over the top, meaning that this can be stored away easily and quickly after a lab has taken place. Finally, another system benefit, one that goes, I guess, without saying really, when you're working with liquids, you have to be very careful about safety and very careful about leakages and things like that. The hoses that we use are the real tubing and hoses that would be used in industry by professionals. So that helps the students to get to grips with using these. And we also use robust rubber gaskets, which allow for reliable sealing to reduce the leakages and in many cases just eradicate them altogether. So a number of benefits that you'll see there. And again, at the bottom, I have linked another playlist, which are the individual experiments that I talked about. So you can click on that to view those again on our YouTube. So that brings me on to tell you what's included in this new product from Matrix. First of all, it's important to point out the main heartbeat of the system, the main area, which is the workstation. You can see two images here, one on the left, which is the workstation with an experiment set up. And on the right there, we've got the workstation as a standalone system, so you can just see how it's set up there. You'll notice a number of things. You'll notice the rugged steel enclosure, which is long-lasting, hard-wearing, as I've already explained. You'll notice as well that the panel has holes in it, okay? And the holes are for users to easily clip on the required components to build the experiments that they want to deliver with their students. And this is done using swell latch technology. Swell latches are something that we've used quite extensively now on 3 or 4 product ranges from Matrix, including structures and fundamental mechanics. They're very rugged, work really well, and that's working out well for us. So that's how components are clipped to the panel for experimentation. On the back of the system, you've got 2 water tanks, and they have a combined capacity of 3 liters. Okay, they're just on the back of the system. All of this comes together to allow students to quickly set up each experiment individually. Then we talk about storage. So with storage, what you'll see is on the top of the tanks on each end, you've got the flow pipes, okay? These flow pipes, which I'm just circling with my cursor there, actually drop down into the frame of the system in order for this to be easily taken from one lab to another or one place to another or put into storage at the end. As well as that, the drip tray, which you can see sat at the front of the system here, moves up and fixes over the top of the components in order for the system to be packed away and stored at the end of a class or the end of the lab. Not only do components go on the front, but other components also go on the rear as well. So on the back, in between the 2 tanks, which you'll see in a couple of slides' time. Further information here on what else is included. So we've talked about the workstation and the great features that this has. Let's talk just briefly then about the individual apparatus and components that are included in this system to allow students to put these experiments together. First of all, you've got the controller or the control box, as we call it. So that's built on a powerful DSPIC microcontroller. You can see it lit up with the backlit LCD just in the top right of the panel, just on the screen just there. As well as that, you have a number of other system features. You have the pump module and a pressure sensor and flow sensor. You have Borden gauge calibration, which is just at the back at the bottom of the panel there. You have the multi-tube manometer and the U-tube and incline manometers, which are just underneath at the bottom right down here. Okay. We then have the losses in bends apparatus, which I'm just circling right here. And then we have viscosity apparatus, center of pressure, and finally our Venturi tube. Okay. All of this comes together in order for the students to conduct the experiments that we'll go through and introduce you to in the curriculum. Finally, you have the rubber gaskets, the piping, the tubing, and all of that's included in the image that you see on screen. We've talked a little already about packaging and storability of the equipment. It's something that we take really seriously. The ability to store and pack away a system is something that we receive feedback is really important. So this is a truly portable solution that can be packed away and moved lab to lab for varied laboratory use. These 2 renders that you see on screen here are firstly on the left, a view of the back of the system when it's packed away. What you'll see here is that the components are not only packed away on the front, but a number of components are on the back of the system and covered away nicely by a plastic molded cover, which means that this is very safe. I'm not going to see any damage when it's packed away in a lab or in a technician's office or something like that. On the right side, you'll just see a side-on view of that straight through one of the tanks. You can see how the system goes together on the back and the front. There are specific homes for the individual components, and that is printed on the plastic mold so that you can see exactly where each individual component is meant to live. We then have final piece of apparatus across the top of the system, and on each end you will see the carry handles. Now, this system with no water in is comfortable to carry. one person just about manage it. With water in the tanks, one person at each end can easily carry this from one lab to another, or from one building to another, even if it's required. So this is a portable solution that just plugs in very easily, and then connection via USB into a laptop or PC for the data acquisition, as we'll show shortly. Okay, so what do students learn? That's really important when we're introducing new equipment, is to understand what your students will learn by using this equipment. Now, in the curriculum, you'll find a section where all of these learning objectives are presented and delivered in more detail, but we've just picked a few of them out here for you in this presentation so we can just briefly introduce you to them. The curriculum allows students to understand the calibration of a boredom gauge, allows students to understand center of pressure on a partially and fully submerged plane. And we have viscosity apparatus, which allows students to demonstrate Stokes' law. We introduced the use of manometers and different types of manometers, including the multitude manometer, U-tube, and inclined manometers as well. Students understand about Bernoulli's equation, using a Venturi tube as a flow meter. Students understand losses in bends, measuring and comparing pressure losses of different bend geometries. So we have an apparatus for losses in bends, which features a mitre bend and two more or less gradual bends as well. And we then have a series of experiments on pumps, and the pumps experiment is one of those that we're going to show you just very shortly. So we have centrifugal pump characteristics, which experimentally determines the pressure flow rate characteristics of a pump and the overall efficiency of the pump. Then we touch on series and parallel pumps in the same particular way. So those are a number of the learning objectives that you can achieve by utilizing this equipment with your students, and you can get more information on those by looking in the specific area of the curriculum noted as the instructor guide. Here, on the next slide, we see example of the curriculum. So just to kind of give you a flavor, if you're unfamiliar with Matrix products, how we set up most of our curriculum now. We begin with an introduction. So introducing the apparatus and the experiments and what the student needs to do to set this up and get this working from the very beginning. So that's the introductory part of the curriculum. We then move on to introduce a series of worksheets. And on the left side screen grab, you'll see the 9 worksheets included in this particular product. Those worksheets explain how to set up each experiment individually, where the connections need to be, nice graphical drawings about how to connect up the different apparatus and kits. Okay, so that's done very simply and very easily there. And then we have a student handout. So the student handout, you'll see from the bottom left image on the screen now, just down here. Here you'll see the tables, the graphs, etc., that the students need to complete as they conduct the individual experiments through this curriculum guide. So the student handout is the next section, and then the final section is what we call the notes for the instructor, or the instructor's guide. Now, the instructor's guide goes through each individual experiment, how to set it up, what the students will learn from it, the concepts that are involved, and importantly, the timings. So roughly speaking, this is about 8 to 10 hour course on fluids. Is that about right? Yeah. And each individual worksheet takes somewhere between 40 and 60 minutes to complete on average. Of course, some may take longer, some will be shorter than that. But it's a nice chunky course. So that's how the curriculum's set up. As I said earlier, the curriculum is freely available on our website. So you can visit and view that at any time. Okay. Okay, so what we're going to do now is we're going to look at one of these 2 experiments. So we have a losses in bends experiment, but we're going to look at pump characteristics. And that's the experiment that we've got set up next to us here. So here we're going to learn about pump characteristics and setting a pump voltage to 24 volts and the resulting flow rate that is maximum for that setting of the flow control valve. Then we step the pump voltage down to 6 volts and monitor the effect on flow rate as we do that. Here we're introducing concepts such as centrifugal pumps and pump efficiency. And this particular topic will take typically about an hour to complete. So if you just bear with me for 2 minutes, if that, I'm just going to switch over a camera, stop sharing my screen with you, and then we'll be able to make a start. All right. Okay. Okay. So I'm hoping that you can hear you can see the experiment on screen. Very clear for myself. If there's any problems, please feel free to pop it into the chat. Okay, and Michael, I'll hand it over to you to explain what's going on here.
Okay, so first I'll just run through what each of the modules are and what sequence are all connected in. So obviously we have the workstation. This is the outlet from the water tank. So that's just providing the supply of water. We have a quarter turn valve, so that is off, that's on. And then these are the hoses that we use to connect all the components together. So it's going from the outlet into this, which is a splitter module. It has two functions. It's a splitter module and it's also a pressure tapping. So you can see here we have this pneumatic tubing, which is actually connected to another of our modules. This is the pressure sensor. So that is just taking a pressure reading. This port at the minute is not used in this configuration, but it is needed in two of the other configurations. So from the splitter, we're going to a pump. So that's supplying water to the pump. And then from the pump, we're going to another splitter module to get pressure reading again. Sorry, too quick there.
That's right.
So that again is going to our pressure sensor. So that's a differential pressure reading before and after the pump. And then from the top splitter module, we're going to our turbine flow sensor. So we have a good idea of flow rate. And then from there, we are going to just a gate valve. So that is just providing us some flow resistance and control to that flow resistance. So, oh, sorry, I missed the control module. So the big part of this is the control module. So we have two outlets for two pumps, outlets for two flow sensors, and also outlets for two, sorry, inputs, I can say, for two pressure sensors. So two flow sensors, two pressure sensors, two pumps, so we can set up whatever we want with those components. So, as Liam said previously, we're going to sweep down from 24 volts. I'm going to have initially we'll have this fully open. We'll see how that see the behavior of the pump. So we're going to be measuring differential pressure before and after, and also flow rate. So we should be able to plot pressure versus flow. So that's going to be done automatically within the software. So you can see. So we have flow rate here. Oops, that was too quick. Sorry. Just repeat that. So I have my sample period far too low there. So we have full control. All these columns have different parameters we can set. So I just had that sample period is down very, very low. So I'll repeat that again. Got 2 seconds between each sample reading now. So there's a delay to get the pressure sensor up to pressure. So we have the first plot here, second plot, it's auto scaling as it goes. You can see each plot coming in. So you get a full system curve there for that particular system. What we'll do next is we'll change the valve settings, so we'll close this valve slightly once it's finished. Almost there. Last one, I think. Okay, so we'll close that a little bit. So maybe full turn there. check the flow rate is sensible. So close it a little bit more. You can see the flow rate's going down as I close that valve. There we go. So getting, as the gate valve starts to close, you get a drop in flow rate as you'd expect. And we should be able to do another automatic sweep. We should get a different plot this time, which again is the system curve for that arrangement. So with the gate valve slightly closed, we've changed flow resistance there. And you can see that curve comes in. And of course, all this could be done manually. It's just this seems a lot quicker and a lot nicer to demo to you today. Yep. Okay. Cool. Yeah, I think that's about it.
And I think, do we have an example?
Yep.
Results.
Yep. So this is full set of results from the three main experiments. The single pumps we have. That's basically the one that we've just been doing. We probably did this plot and this plot, and then all of it's all the scales are the same. So this is 0 to 100,000 pascals. You can see the characteristics are very different for a single pump and for parallel pumps. You get very different characteristic curves. Yep, and obviously you can interrogate all the data is there, so we can also look at voltage, pump current, flow sensor 1, pressure sensor 1, so on. We can get all the useful information out there, so we can plot efficiency, power, all that stuff. Great. Yeah.
Okay, thanks very much for that, Michael. Hopefully that helps to just apply a little bit more to your knowledge of the product other than the presentation that I delivered. So just give me a second. I'm just going to move back. Okay, thank you to Michael for showing us that. Hopefully it did help to add a little bit more context for you. Just looking at a few comments that are coming in there about the software and the interactive nature of the software. That's great. There's no specific questions. Yeah, it definitely helps students to find everything more understandable. And of course, the ability to export data into CSV file means that further analysis can take place, but much of what's needed for the teaching purposes is within the application software that we provide with the system. And there's no extra charge for that. It's just part and parcel of what you get. So does anyone else have any more questions before we conclude? Hopefully that half-an-hour session has given you a little bit more information about this product and a little bit more food for thought on where you might be able to utilize it more in your teaching. Okay, I'm just looking there. Mazin, pump characteristics test. Sorry, what specifically are you questioning there? What are you asking?
That's what we just plotted. So we plotted pressure versus flow rate.
Yeah,
so that's differential. So that's from inlet versus the outlet.
What we do have, Mazin, is the graphs that we just provided. We can provide example results for all of this equipment. So for all of the experiments that can be conducted, including pump characteristics and the differences between centrifugal, series and parallel pumps, and then the way that the results differ, we can provide you with the results graphical graphics so that you can see those before you maybe invest in this type of a system. So we've got a document, I think, haven't we, that we can provide that shows that. Yeah. Okay. Just drop us an email and we'll provide that to you. One thing that I want to do before we just finish And again, if anyone has any more questions, please feel free to ask. Is just to briefly explain that if anyone has any questions, contact us at these details. The website's very simple and full of information, including the curriculum. You can also get more video from there. We'll put a recording of this webinar, or maybe the one that we did earlier today, on our YouTube. So you'll be able to find the recording of this to send out to your customers if they couldn't make it today, or your colleagues if they couldn't make it today. You can call us anytime. We're in the UK on the number on screen, or you can email us. Now we have, as I explained earlier, earlier on, in almost every country around the world, we have partners, dealers, agents that sell these products for us and supply the market direct with their technical expertise. And so if you are interested and you're from outside the UK, the chances are we'll put you in touch with them. What they'll also be able to do is to share with you the pricing of this system. So if you're interested in knowing the price of the product, please don't hesitate to get in touch, and we will provide that information for you as well. Okay. Here in the Middle East, or there in the Middle East, should I say, Mazin, we work with Ednex. So we can put you in touch with them. Please do email us at sales@matrixtsl.com, or you can send me a private message in the chat with your email address if you want us to share that with them. And we will actually be at the GES exhibition in Dubai in November, and we will have this product there with us as well. So if you'd like to see the product at GES in Dubai, please let me know, and we can arrange a time and an appointment out there with you to show you it. Okay. Yes, we can certainly share the PowerPoint with everyone. I would again ask you to email us. If you can email us at sales@matrixtsl.com, sales@matrixtsl.com, please send me a message there and we will share this with you, because we don't have everyone's email addresses without you asking us for the presentation. So we can share a recording, the presentation, and results documentation with you as long as you email us straight afterwards. And Mazin, I will ensure that I send you the details of our agent and share that with you shortly. Okay. Okay. If anyone would like any further demonstration one-to-one or discussion, please don't hesitate to get in touch. I think we'll conclude it there for now. We will post this on our YouTube later today, so that yourself, colleagues, customers, etc., can share this with one another and ask any further questions that they may have. But I thank you very much for your time today. It's been a good session to just introduce you to this new product from Matrix, and we are very positive and excited by the way that this is starting out in terms of its sales. Have a good day. Thank you.
Thank you, Liam.